8.3, and we're looking at the algebra of functions. First objective is to find the domain of a function. So it says, if a function f does not model data or verbal conditions, its domain is the largest set of real numbers for which the value f of x is a real number. Exclude from a function's domain real numbers that cause division by 0. Also exclude from a function's domain real numbers that result in a square root of a negative. For Math 102, we actually are going to ignore the second condition and only focus on the first condition. So any value of x that we plug in that will cause us to divide by 0 cannot be included in the domain. So what is this basically saying? So if you have a function, so if given a function and there is a denominator, so if given a function and there is a denominator, you're going to set the denominator not equal to 0. And then you're going to solve for x. Okay? If given a function and there is no denominator, then for this class only, in Math 102, the domain will be all real numbers. And that's from negative infinity to positive infinity. So the one thing you should look for when finding the domain of your function, whether or not the function expression has a denominator. If there isn't a denominator, then the domain is all real numbers. If there is a denominator, set it not equal to 0 and solve for x. Alright, so they say consider the function f of x equals 1 over x minus 5. Notice that we have a denominator. So since we have a denominator, we're going to set it not equal to 0. And then we're going to solve for x by adding 5 on both sides. And we get x does not equal 5. So the domain would be all x values except for x equal to 5. Okay? Because if you take 5 and plug it back in for x, you will end up with 1 divided by 5 minus 5, which is 1 divided by 0, which is undefined. Therefore, 5 cannot be in your denominator. I'm sorry, 5 cannot be in your domain. Let's look at more examples. So it says find the domain of a function. And we have f of x equals 2 divided by x minus 4 plus 6 divided by 5 plus x. We see two denominators. So we're going to set them both not equal to 0. So we have x minus 4 does not equal 0. 5 plus x does not equal 0. And then we're going to solve for x. We're going to add 4. And we get x does not equal 4. And we're going to subtract 5. And we get x does not equal negative 5. So if we wanted to give an interval answer, first start by drawing a number line. Place negative 5 and 4 on your number line. Because it's not equal, is going to be a double parentheses, one facing to the left, one to the right, on both tick marks. And then you're going to shade everything else. Arrows at the end. And starting from the left, we have parentheses, negative infinity, comma, we run into negative 5, close your parentheses, and then union, this means or, and then parentheses, negative 5, run into 4, close parentheses, again, union or, parentheses, 4 to infinity. So this interval represents your domain. It's basically saying x can be any value except for -5 and +4. Alright, it says find the domain of f of x equals 1/2 x plus 3. Well, we look here and we do not see a denominator. There's nothing dividing. There's no x in a denominator. Therefore, the domain is going to be all real numbers. When it's all real numbers, you can take any value from inside this interval, plug it in for x, and you can expect to get a value back. Alright, last example, it says find the domain of g of x equals 7x plus 4 divided by x plus 5. So again, we see a denominator. So we're going to take our denominator and we have x plus 5 does not equal 0. We are not concerned with our numerator, so we don't need to do anything with it. Solve for x, and we get x does not equal -5. Now let's try to write our interval answer, so I'm going to put on a number line so we can see it. Not equals means double parentheses, and then you shade everything else and put arrows. And then starting from the left, we're going to start at -infinity, and we'll run into -5, and then it's union -5 to +infinity. And this will be the domain of our function. It basically says x can be any value except for -5. Okay, so this concludes our video for 8.3. Please email me if you have any questions.